So now the fun begins. We've learned about equations and inequalities and just algebraic thinking in general. Once we translate this now to solving problems, this is challenging because you are going to have to build equations from scratch. And there's a process for doing this. Um, Everybody's going to take a different approach, though. We've looked at using tables to lay out your information and then build an equation or an inequality from there. I'll give you some other strategies here, but this takes time and this takes some practice. Back at the very beginning of the first video, I gave you this problem opener. And so let's take a moment to explore this. It says a whole brick is balanced with a 1 pound brick or with 1 pound and 3/4 of a brick. So what is the weight of the whole brick? So we've now maybe seen we can use an equation to help us solve this. And so what we might say is, all right, I'm going to let the brick be the variable B. That's the thing that I'm searching for, the weight of that brick. So on one side of our equation, we have a single B. On the other side of the equation, we have this 1 pound, so that's just the number one, plus we have 3/4 of a brick. So that is 3/4 of a brick. Okay, so we need to solve this equation. If you use the balance scale to help you with this process, one thing that you could do is say, all right, well, what if I eliminate this thing, this 3/4 of a brick? If I cross that out and eliminate it, I'd also have to eliminate 3/4 of a brick from the left side. So imagine we could just chisel part of this brick away. That would be subtracting 3/4 of a brick and 3/4 of a brick from both sides. If we do that, how much of this original brick do we have? 1/4 of it. We're taking one brick. When you have a variable with no number in front of it, it is that there's just one of them. And we're subtracting 3/4 of a brick. It leaves us with 1/4 of a brick. That's equal to 1 pound, a 1 pound weight. This we've eliminated. So 1/4 of a brick is equal to 1 pound. Now, hopefully you can logic your way through this. Again, if you imagine 1/4 of a brick balancing with 1 pound, then we want to know, what does the full brick weigh? And if 1/4 of it weighs 1 pound, then we would know each fourth of it would have to be would weigh another pound. So this would weigh one, this would weigh one, and this would weigh one. We would have to multiply by 4 on both sides of this balance scale. If you look at your equation, if you multiply both sides of this equation by 4, 4 times 1/4 turns into one full brick. 4 times 1/4 is just 1. So it gets us back to just a single B, and 1 times 4 is 4. We use the subtraction property of equality and the multiplication property of equality. But hopefully what you're seeing here is how the images can help you make sense of these problems. So the next thing we're going to do is this question here. And I'm going to walk you through the process of how to think through this and build an equation that's going to help you solve this problem. It says a slice of pie with a scoop of ice cream has 450 calories. The calories in the pie alone are 100 more than twice the calories in the ice cream alone. How many calories are in each food? We got a plate. On that plate is a slice of pie and a scoop of ice cream, right? We have pie, we have ice cream. And it gives us information about their calories. And we need to find how many calories are in each food. The strategy that I love for when you have to solve a problem like this is start to see, can I write out my equation using words? So this scenario can be stated in words by saying the pi calories plus the ice cream calories are equal to 850 calories. That's sort of the most basic information that we have from this scenario. The first question tells us that a slice of pie with a scoop of ice cream has 850 calories. So we can state it like that as an initial, what I call word equation. So that's one way you can start this process. The next thing that I think is helpful is to identify your variable. When we're building an equation, we're going to have to use a variable at some point. In this problem, this can be a little tricky because we're asked to find two pieces of information, the calories in each food. What a lot of people want to do in this case is say, okay, could I just say this is P and this is maybe C to be 850? Pie plus ice cream equals 850? Yeah, but you're kind of stuck there because then what you have are two different variables. And solving an equation with two different variables, we haven't gotten there yet. We can't actually do that yet. So I'm going to say that's not quite it yet. So one of the things that we want to do is we want to look in our explanation, in the description of the problem, and look for a scenario where one piece of information is based on another piece of information. And we find that right here, this second sentence. It says the calories in the pie alone are 100 more than twice the calories in the ice cream alone. And so that sentence is saying that the calories in the pie, at least for our calculations, are based on the calories in the ice cream. If we knew how many calories were in ice cream, we could then figure out how many calories were in the pie. Once you've identified that, it helps you tell which you want to be your variable. Whichever piece of information the other thing is based on, that's what you want to be your variable. In this case, we're going to let our variable, we'll just state it's x. X is going to be ice cream calories. X is going to be the number of calories in the ice cream. Again, because if we knew that, then we could figure out the calories in the pie, because it says the pie has 100 more than twice the calories in the ice cream. So again, if we figured out the ice cream, we could then work backwards and figure out the pie. So our equation is starting to come together a little bit. We're going to be replacing this piece of our word equation with our variable. So that's the next piece. We start to build our equation. So how do we deal with this thing? The pi calories. What we have to do next is create an expression. So we use this highlighted green information to build an expression that represents how many calories are in the pie. It says that the calories in the pie are 100 more than twice the calories in the ice cream. So if we doubled the number of calories in the ice cream, 2 times x, 2 times the ice cream calories, and then added 100, that would be the amount of calories in the pie. Again, if we knew how much the ice cream had, we could double it and then add 100, and that would be the calories in the pie. So 2 times x plus 100 is the number of calories in the pie. We now have the variable that represents the ice cream and the expression that represents represents the pie, and we have the total number of calories in both. So if we write out our equation like this, 2x plus 100, there's our pie, plus x, there's our ice cream, that will equal 850. We've now built our equation. Again, we laid out our word equation, we found the variable, we built an expression based on that variable, and then we put it all back into the equation. Again, this right here is the pie, this right here is the ice cream, and this right here is the total for both of them. Now let's go ahead and solve this equation. On the left side of our equation, the first thing we'll do is we will simplify it by adding our 2x and our x to get 3x. Remember that 2x means x plus x. So what we have on this left side of the equation are 3 total x's all added together, plus 100 equals 850. If we were writing out what our step was, this would be simplify. The next thing we would do is we would subtract 100 from both sides. This is the subtraction property of equality. Are you able to picture a balance scale as we go through this process? We then simplify to get 3x equals 750. Now we are going to divide by 3, our division property of equality, and we get x is equal to 250. Once we've solved our equation, now we return to where we created our expressions back here at the beginning. X was the number of ice cream calories. We've now calculated the value of x, which means the ice cream we know has 250 calories. We also know that the pie has twice x plus 100. So if we take 2 times 250 and then add 100, we get 500 plus 100, which is 600. That means our pie will have 600 calories. And if we check to make sure that 250 plus 600 is that total, we see that those do add up to 850 calories. So before we move on, just a quick recap of this problem. Zoom out a little bit so we can see all of it. Often, we're given a scenario where you can state it using words. State the scenario in words. Then you take each chunk of that word equation and start to build them individually. You have to figure out how to do that. The way we do it often is find one variable, one piece of information that's based on another piece of information. Whatever it's based on is going to be that variable. In this case, it was the ice cream. From there, we can build out the more complex expression for the other piece of information. Now you can fill in all your information in your equation, and then you can solve it. Once you've solved it, you return back to the beginning and substitute that value in for the variable anywhere you need to calculate your final response. Again, this is not an easy process. In fact, it's a bit complicated. We do have to practice this a little bit. So here's another scenario. It says the manager of a garden center wants to order a total of 138 trees consisting of 2 types. Let me expand this a little bit. Japanese red maple and flowering pears. Each maple tree costs $156 and each pear tree costs $114. If the manager has a budget of $18,000, which must be spent on all the trees, or which must all be spent for the trees, how many maple trees will be in the order? So I would love for you to try this on your Again, see if you can start with a word equation that represents the whole problem, and then see if you can figure out what your variable is, and then see if you can build another expression based on that variable. This one's a little different than the previous question. Once you do that, you should be able to build an equation and solve it. I want you to struggle through this at first, and then I'll walk you through the process. So the way we're going to start this, and I hope you've tried it first, is I like to lay out our word equation first. The first thing we know, the most basic thing we know, is that we have maple trees and we have pear trees. And both of them are going to have some cost associated with them, right? So that we have the maple cost and we have the pear cost. And the budget, the total of that has to be $18,000. So again, we're going to spend money on both types of trees, and it's all going to add up to $18,000. So there is our word equation that we can start with, something like that. The next thing we might do is even add to this a little bit. We know the cost of both individual trees. So I can say that $156 times the number of maple trees, that will tell me the cost of all the maple trees. Similarly, I can take $114 times the number of pear trees, and that will tell me the cost of all the pear trees. That is going to equal $18,000. So in a way, in this case, we were even able to like take our word equation and manipulate it a little bit before we even had to introduce our variable. So now we've got our next little problem to figure out. Again, we've got the values of both of the trees, the cost of both trees. We've got our total cost. What we're left with is this part of the problem: the number of maple trees and the number of pear trees. You might be tempted to just use M and P, but that's not good enough because we can't have two different variables. We've got to narrow it down to one. So that's where this piece of the information is going to come into play. We have a total of 138 trees. So what does that mean for our problem? Well, one way we might interpret that is that the number of maple, I'll use this for the number sign, number of maple plus the number of pear, if we add them together, has to equal 138. So how can we use that information to help us? I'm going to use X as my variable just because it's sort of a standard piece of information. So what would happen if I said X is equal to the number of maple trees? How many pear trees would we need? So if you got stuck in this part of the problem, I'm going to let you pause the video again and think about, if X is the number of maple trees, what expression would represent the number of pear trees? Go ahead and try that. A visual can help you with this process. So imagine I use this box for all my trees, and I say this box has to have 138 trees in it. And I just put a random line down the center of this box somewhere. And I say that on this side of the box will be the maple trees, and on this side of the box will be the pear trees. And I'm going to let the letter X represent how many maple trees that is. How many are left to be pear trees? Does that help you make sense of it? If we have to have a total of 138 and X number of them are maple, 138 minus X have to be the pear trees. Again, if the total number of maple will let be the X, and 138 is the total of all the trees, we would subtract X trees from 138 to tell us how many pear trees there are. So the pear trees will be 138 minus however many maple trees there are. I told you that was a little bit challenging, but this is what our new equation will look like. 156 times X, because X is the number of maple trees, plus 114 times 138 minus X. That's the number of pear trees. That is equal to $18,000. Again, pause and stare at this. Go back and rewatch some of this and maybe listen to the explanation again, because I think this is one of the more challenging things that we do in algebra when we're trying to solve problems, building expressions based on certain pieces of information. So again, just to recap what we've done so far, 156 is the cost of every maple tree, and X is going to be the number of maple trees. 114 is the cost of every pear tree, and 138 minus X is going to be the number of pear trees. The total is going to be $18,000. So let's solve this equation. We will start by applying the distributive property. So that's actually the first step, is to apply the distributive property. 114 times 138 is 15,732, and then minus 114 times X. That's equal to 18,000. All we did was distribute. That's the property that we used first. Now what we will do is simplify, because on the left side of our equation, we have a number of X's. And we're going to do that subtraction, 156 minus 114. We're going to simplify that. This is called combining like terms. That leaves us with 42 X's on the left plus 15,732, and that's equal to 18,000 on the right. We can then use the subtraction property of equality to subtract 15,732 from both sides, leaving us with 42x on the left, 42, remember we talked about boxes on our balance scale, equal to 2,268 on the right. If we now use the division property of equality, divide by 42, we end up with x is equal to 54. That means if x is equal to 54, and I zoom out so we can see the entire problem, what did x represent in this problem? It represented the number of maple trees. The variable was the number of maple trees, and that was the question. How many maple trees will be in our order? So our answer is 54 maple trees. And so I hope what this has helped you with is seeing how you can use algebra to solve some problems. Again, it requires a lot of thinking, and you're not going to be able to jump right from the scenario that was written for you into building the equation. It is a process. It requires lots of algebraic thinking. And the biggest piece of algebraic thinking, again, exists right here. So your job is to draw pictures. It's to draw balance scales. I gave you scenarios here that were equations, but sometimes you also need to represent that with an inequality. And so that concludes this section. Again, I think this will be the most challenging piece to the process. It takes lots of sitting and staring and thinking and just trying different things until you're able to get to this point where you're able to build that equation. But again, always remember to define your variable, write stuff out so you know exactly what everything represents. So at the very end, you can always go back and check what you have.